So the problem states to explain how to determine how many of these molecules are polar, explain the overview of the procedure and a detailed explanation on how to draw one of the Lewis structures, then explain how to find partial charges and bond dipoles and how to find the net molecular dipole for each molecule. And then the molecules include SO3, LF2, BeCl2, CCl4, and O3. So first I made an electronegativity chart of all the electronegativities in all the atoms from above just to be more organized. And then I also made a polarity rules chart in case I needed it. So the first molecule was SO3, and to get the total of electrons, you use the valence electrons, and in S it's 6, and then there's 3 oxygen molecules which also have 6 electrons, so when you add that all up you get 24. So then you'll draw the Lewis structure, and the S would go in the center because there's 3 oxygen molecules, and then first you put 1 bond on each, and then you add the outer electrons on oxygen, and then since it's 24, to make it even, you have to make it a resonance structure where the electrons are shared between the final 3 oxygens to get the 24 and to get all the bonds to be even. And then there's a partial negative on the sulfur atom because oxygen is more electronegative than sulfur. So then the bond dipoles will be going towards oxygen, and the positive part would be at the sulfur. So this molecule is a trigonal planar molecule, and all the bond angles are 120 degrees, and there's no net dipole because all of the domains surrounding the center atom are equal and the same, so therefore the molecule is also nonpolar because there's no net dipole. So the next molecule is OF2. So again, there's 6 valence electrons on oxygen, and then there's 7 on fluorine, then you have 2 fluorines, so that's a total of 20. So then you draw the Lewis structure, and the oxygen goes in the middle because there's 2 fluorines, and then there's oxygen likes to have 2 bonds, and then fluorines each like to have 1 bond, so they're both single bonds, and then there's 3 pairs of electrons on the fluorine and 2 other pairs on the oxygens. The oxygen has a partial positive because fluorine is more electronegative than oxygen, so therefore the bond dipole will be pointing towards the fluorine. And it will also be a little bit smaller than the previous dipole because fluorine and oxygen are more close in electronegativity than sulfur and oxygen. This is a bent molecule, and the bond angles will be less than 109.5 degrees. And because it's bent and the domains are not equal, there will be a net dipole. So then if you make these to where they're more straight, so it'd be easier to add together, the 2 pointing to the sides are equal, so those will cancel out, and then the other ones point downwards. So then the atom will be more electronegative towards the bottom, and more positive towards the top. This is a polar molecule because the bond dipoles don't cancel, and yeah. So the next molecule is BeCl2, and beryllium has 2 valence electrons, and chlorine has 7, and since there's 2, then you have to multiply it by 7, and so that's a total of 16 electrons. So beryllium goes in the middle, and it's a single bond towards each chlorine, and there's 3 more pairs on each chlorine. There's no more valence electrons on beryllium, so you don't have to add any more pairs. And then this is a linear molecule, so the bond angle will be 180 degrees, and the dipoles will be pointed towards the chlorine because it's much more electronegative compared to the beryllium. There's no net dipole because the bond dipoles cancel, so therefore the molecule is nonpolar. So then the next molecule is CCl4, and then calcium has 4 valence electrons, and chlorine has 7. And since there's 4 chlorines, then you have to multiply it by 4, and when you add it together, you get 32 valence electrons. So calcium goes in the center, and there's a chlorine on each side of it. So this is a tetrahedral shape, and the bond angle will be 109.5 degrees. The calcium will have a more partial positive charge, and all the chlorines will be more partially negative because chlorine is a lot more electronegative compared to the calcium. So therefore the bond dipoles will be pointing towards the calcium. The bond dipoles will be pointed more towards the chlorine. And because all of the because all of the domains on the center atom are equal, there's no net dipole because the bond dipoles cancel, so therefore the molecule is nonpolar. And finally, you have O3, which is ozone layer, and so you have 18 3 times 6, so 18 electrons. And so if you try and draw it like this to where they each have the correct number of valence electrons, it would be too many electrons. So therefore, there be a double bond on at least one oxygen between two, at least one oxygen pair. And so you get this resonance structure where one pair of electrons is shared between all 3 atoms. And then because the molecule is bent, and so therefore has a little bit less than 109.5 degrees between each angle of the domains, there's a more partial positive towards the top where the lone pair of electrons are, and then more partially negative towards the bottom where the other 2 oxygens are. And then because the net dipoles are not equal, because the domains are not equal either, because there's 2 lone pair electrons and 2 oxygens, and then therefore this molecule is polar because the net dipoles will not cancel, and this atom, the dipole will be pointed downwards like this. Some common mistakes include when bond dipoles are pointed towards the wrong way. For example, if you, on this molecule, if you pointed all the dipoles upwards instead of towards the chlorine, and you pointed it towards the calcium. And then another thing that could go wrong is if you get the molecular geometry wrong. For example, if you forgot about the extra valence electrons on the center atom, you might say that this molecule is linear rather than bent. And finally, if you forget about octet violations, for example, beryllium only has 2 valence electrons, so therefore it won't have an extra 2 pairs to make it an even 8, because there's only 2 to bond with, so they don't have any more to share.